Good evening, gentlemen. So last evening we figured out what was on that BIOS setup partition on the old disk drive over there, and got the files off of it and backed them up to the DOS partition. I'll copy them off of there onto a floppy and put them somewhere safe after a while. Things are going pretty well with the ProLinea 450. Slackware takes forever to boot, but that's not entirely unexpected. I didn't expect it to boot quite that slowly though. It runs fine once it's booted, but it takes a very long time to calculate module dependencies, and there's one other place where it hangs up for a while. I don't remember off the top of my head what it is. Anyway, we do have a couple of problems. Strange things that are going on. So this 40 gig drive here, it's got jumpers for master, slave, and cable select, and I discovered a while back that it had no jumpers on it at all. Nothing was jumpered on there. So I put a jumper on master, and it works fine in DOS that way. I guess DOS uses a PIO BIOS driver, so it worked fine in DOS that way, but in Linux it was giving not necessarily random, but strange, predictable drive not ready errors, especially during startup. It was quite bizarre, and so then I got a wild hair, because I'd been using the drive without any jumpers on it, and it just showed up as a master. I got a wild hair and just pulled that jumper off, and that solved the entire problem. I haven't tried it with cable select jumper. Maybe I ought to, but so yeah, that's a little strange. At first, when I was getting those drive not ready errors, my first assumption was that extra connector that we soldered in on this side, the extra ISA connector, there was something wrong there, because, you know, most of the time when something goes wrong after I've soldered on it, it means that I've made a mistake somewhere. But so that's why the IDE controller is in this this top slot now. But that didn't make any difference. I just haven't moved it back to where it's supposed to be yet. So we're going to move that back, and I'm going to try, I guess I'll try the CS jumper and see what happens. I might as well just leave it how it is though. And also, I didn't think about this, but using the expansion card, of course, we don't have a hard drive activity LED in the front that works, because it's tied to the internal interface, which we're not using anymore. So I'm going to have to come up with something for that, and I have some ideas for that. So yeah, here's another issue. I'm not sure what is going on here, but I can't get any DHCP response, and when I try to configure the network interface manually, I still can't ping anything or see any activity on the wire other than this machine. But if I go up here and look at my switch, why, there's activity on well, there was activity. Oh, it's in a DHCP request. You can see a black blip every now and then there. There's activity on the line that goes to that machine, and there's activity on the line that goes down the stairs to the router. So I don't know what's going on there. There's a link light. The router sees this switch, and the switch is passing the data through. So I don't know what's going on with that. Maybe there's something wrong with the card. Another thing is, so we had set this card to IO port 1E8, this IDE interface, and I had originally left it on IRQ 15, and I'd gotten it working fine in DOS like that with the XD-IDE BIOS, treating this as the first interface and the internal interface as the second interface. But Linux, Apparently it's hard-coded into the kernel. I can't find anything in any of the documentation about passing parameters to Lilo to change this, but apparently Linux always probes first the default two IDE ports, and then it probes for one on 1E8 that this is set to on IRQ11. And that was causing trouble. Nothing would work after the kernel booted, so I switched the card to IRQ11, and Linux finds it and it works fine now, but it thinks this is the third IDE interface, and it thinks that the one built into the motherboard is the first IDE interface. So if you plug a hard drive into the internal interface, it comes up as HDA, whereas the one that's supposed to be HDA comes up as HDB. So that's an issue. We could work around it if we had to, but it doesn't matter because we're not going to have anything plugged into the internal interface. Alright, so I don't know what's going on there. If we look at the if config for ETH0, I mean it's finding an NE2000 card at the correct IO port and IRQ. I put those in modules.conf or whatever the newer equivalent of that is, modprobe.d or whatever, and I think it's got a valid hardware address. Yeah, so, or does it? Can an Ethernet address start with zeros like that? Is there something wrong here? I'll have to do a little bit of internet searching on that. That may be the problem right there. If the Ethernet address is wrong, it's no wonder that the router doesn't want to talk to it. Or if the Ethernet address is invalid, I should say. Anyway, let me put you back on the stand here and let's look at something else. So I was talking earlier about how now that we're using this this external interface card for the disk drives, we don't have any hard drive LED on the front working. So let's take a look at this XT-IDE card for some clues on how we might go about fixing that. This card has a LED, an activity LED built into it here. If you look here, one leg of that LED, let me find a pointer here. Put this down here where you can see it a little better. And I won't have it off the camera. Oh, focus, you dirty rascal. Okay, one leg of this LED comes down here and ties to this power pin on this IC here, right? And then the other leg of this LED comes out and goes up here through this load resistor here, and then it comes all the way across the top here and down in between the legs of this bypass capacitor here, and ties in to pin 39 on the IDE header. So that pin 39 must be an active low signal indicating hard drive activity. Pardon me. This is the tail end of that IDE interface card, the end towards the front of the computer, and it's got these components here that haven't been populated. There's a place for a capacitor here, so one side of this capacitor is probably 5 volts and one side is probably ground, so that's a place we could get a 5-volt supply from. But even over here where this, it looks like it's some kind of power header or something, I guess for powering your IDE device off of the ISA bus or something. That seems a little dubious to me, which is maybe why it's not populated, but it looks to me like this middle pin here tees off of this VCC pin on this LS245 chip here, so that we can probably get 5 volts straight off of this pad right here. And if this pad right here, we'll see what it's doing on the other side, but here's the other side of the card, and there's that pad we were looking at. That's a big trace. My supposition is that's probably going to 12 volts, and this is some kind of filter capacitor on the 12 volt line. It's supposed to go right here in that spot. So yeah, that looks pretty promising, actually, if I can get the camera to even focus. If we just cut this trace here somewhere, I'll test it and make sure it really is the 12 volt line, but if we cut this trace here somewhere, then we can get our 5 volt supply probably off of this middle pin, and we can just solder a header into these two, like a right angle header to plug the LED into, right? And then after we've cut this trace, we can put we can solder a resistor, a load resistor for the LED into this pad right here, and then on the other end of that resistor we can attach a bodge wire and heat shrink that so it doesn't touch anything up here, right? And then that bodge wire can come along the top of the card here and connect to pin 39 of the IDE interface right here. When that's high, the LED won't light because it'll have 5 volts on both sides. But when it goes low, it'll ground that the negative side of the LED, and it should light, and we should have a hard drive activity light that way. It's not how you're supposed to do it. Every motherboard that I've seen actually switches the 5 volt supply, or the 5 volt line of the LED, and ground is always grounded. But it'll be fine this way. I mean, yeah. It's possible that let's see, there's a 7400, that'll be a 2 input NAND gate. And it does look like there are some unused pins down here, so we could probably tie the inputs together and use an unused gate on this quad 2 input NAND gate chip as an inverter on that 39 pin of the IDE header, and implement a proper LED that actually switched the 5 volt supply on and off, and then we could tie into a ground here somewhere. But heck with that, you know, no. This is a surface mount chip. It would be really difficult to hook bodge wires to. It's just not worth the aggravation. Yeah, I mean, the chances are that this card will never be used anywhere other than in this machine from now on anyway, so yeah, it'll be fine. So let's I'm gonna put this card back in, and then we can test the voltages here and make sure that we're on the right track here. I don't want to do something stupid. I mean, I'm sure I'll do something stupid, but I want to minimize my stupidnesses before they happen. So cut this thing on here, and let's look at that pin that we thought was 5 volts. 4.99, okay, that's 5 volts. Now let's look at this first one. I think that both of these are probably 12 volts. 11.86, that's a little low in my opinion. And if that's the case, I'll bet these bottom two, well, this one here is, yeah, they're both definitely ground. There should be there is a little bit of a voltage differential from ground to the chassis here. Let's test from the logic ground to, or the ground on the card. Well, it is the logic ground, it's on the ISA bus. 4.99, 11.87, same thing. So yeah, we'll just cut that trace on the 12 volt side and use that to implement our LED. Yeah, that should work pretty good. Alright, hang on a second, let me get this out of the way. We're going to have to unplug we're going to have the wires for the LED go somewhere other than where they're going right now. I'm going to have to get this disk drive out of the way. Hang on a second. You know what, before we even go to all that trouble, let's make sure that pin 39 really does what we think it does. So let's boot into DOS and generate some disk activity and see what's going on those pins. Shall we? Let's see here. Gonna need some sheet wires here. One of these is going to be ground and one of them is going to be what we need. So whichever one we need is going to be positive when there's no disk activity. 3.28 volts, that's pretty low. I don't know why that voltage is so low. What are we showing on the disk drive? It's going to be this pin right here, I think. 3.29. Let's better look at that on the oscilloscope. I think that would be good. All right, our fancy test setup. Let's power up the whole oscilloscope. Whew. Look at the transformer in that thing go. Jeez. Are you gonna work, my old buddy? Come on. Come on. You can do it. You can do it. I need new capacitors so bad, he says. Okay. So, now let's tell it to boot FreeDOS, and we should get activity there. It should go down. The line should go down when there's disk activity. Okay. That seems to be working pretty good. Let's, hopefully it's not too bright in here to see. We have things mocked up here, pin 39 going through an LED and a load resistor, and I'll just hold the other end of this wire on that 5 volt pad we were going to use and cut the power on and hope that I don't have the LED in backwards, because I tend to do that most of the time. And we'll skip the RAM test. I saw a blip when it probed the disk drive. Let's tell it to boot Linux. That'll make a lot of disk drive activity. Well, it seems to be working. Like that. It's loading Slackware. Now it's starting in it. Okay, well I think that's more than sufficient for a hard drive activity light. Alright, there is the header, which is keyed, and the hard drive LED are the green and white wires. You know, I hope, let's see if we can just pull the connectors out of the shroud here without damaging them. I may be able to do this in a happy way. Yeah. We'll have to untape these. Alright, we've got them free of the skeevy tape, and I'm going to have to bend these tabs back up where I pushed them down when I was taking that thing out of the shroud. It's a little too far. Better be careful, I don't want to break them off. Then I'll have to crimp new ones on, and you know how much I love crimping DuPont connectors. Unless I haven't posted that video yet. Alright, let me what drawer? I gotta finish labeling my stuff someday. Is it this drawer? No. Perhaps this drawer. Yes. Now, if we're very, very lucky, we should just be able to stick these into this new shroud and we'll have a magical, happy new connector, all of our own. Yes. Oh, get in there, you dirty rascal. You know, I think that worked. Happy day. Happy day. And we are still completely reversible, and we'll just put a right angle header right there, and then that'll just plug on right like that. Okay, let's make the modifications to the card then. Now I can cut myself and the trace. That will be a keen trick, won't it? Yes. Yes, it will. We should still have continuity between these two pads because we're going to use both of them. But we should not have continuity here anymore to where the 12 volts is. Alright. Snazzy. Okay. Soldering iron. Heat up. Heat gun. Heat up. Desoldering iron. Come to life. Put a little fresh dope on here. Okay. Desoldering gun. Hurry up. Hurry up and get up to temperature. Let's see, we need some wire wrap wire for our bodgification. Where's my wire wrap wire? Wow. Okay. And our breadish board with our resistificator. We'll just reuse that resistificator. It's our fancy 1% tolerance resistor. It came from China, so you know it's high quality. Yes. Yes. Alright, up to temperature. Now, mister, let's desolder you. Yes. Let's do the right ones. That should be all we need you for, my friend. Now, I hope I have single row right angle headers. Single row header male right angle. Oh yeah, I've got enough of them to choke a buzzard off a gut wagon, don't I? Or have I used any of them before? Are any of them shorter than the rest? That's what she wanted to know. No, I guess those are all brand new. Huh. 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 Well, we'll need two of them. 1, 2. And he'll go right there like that. We probably ought to go ahead and plug this thing into the pins just to hold them off of the board enough for it to... Oh, are you going to go on there? You skunk, you better go on there. Oh, you skunker. What's wrong with you? Did I mess up my connector router when I was messing around, pulling it out of the other thing? No, it's... I guess the thingamabob isn't exactly the same. That's alright. Where's my tape? Don't you hate it when people do this and make the tape ugly? I sure do. I sure do. Now, good solder. We don't want to use that lead-free shit. No, sir. No, sirree. Beautiful. 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 Did it come through good? Yeah, that looks good-ish. It looks good-ish. Which is goodish enough for whoish it's forish. Yes-ish. Oh, get out of the way, solder. I'm trying to de-tape the thing. Ah, rage, rage, rage. Why did I buy such high quality tape? Ah. Okay. That's not straight. That's not straight. Look at that thing. That's not straight. It's crookedy-doo. We can't have something crookedy-doo. It will offend our sense of aesthetics. There. Be straight. Very good. Very good. Beautiful. Beautiful-ish. Beautiful-ish. Yes. Okay, now we will need a bodge wire of an approximate length. Alright, let's see if we can create a thing that does stuff here. Set you to the side for a moment, my friend. My friend. My friend. We can use more than that. I'm being too cheap with my wire. Cutter, a cutter, a cutter. Oh, don't hurt me. Oh. One of these is thicker than the other. We'll make our splice ugly as shit. Yes, ugly as shit. Let's just trim that off. Bend it back. Well, that's pretty crappy. Blah, 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 blah. That's alright. That's alright. That's all right. Hey, get up there. Get up there. Solder. Ah, I dropped my solder and it doesn't roll. Oh, now I've got a big mess. Oh no. Oh no. Oh no. Oh no. Oh no. 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 Ah, don't burn me. No, don't burn me. Ah. Too much solder. Too much. Come off. Come off. Too much solder. Ah, I'm tangled up again. Ah. Oh, that'll have to do. That'll have to do. That'll have to do. Now, let me see. Where is my thingaroo? This is, by the way, a 470 ohm resistor. Is this too small? That is not too small. That is just right. Just-ish right. Now, come hither. Oh, get in the stand, you rat. Oh, that'll do, I guess. Alright. Back to the thing. Our pin 39. We have found the correct pin. We'll cut our bodge wire about here. Ah, get out of my way, tools! Arr. Look at this pro fixin' job on my strippers. Is that hillbilly or what? Yes, sir. And they don't strip worth a shit. No, sir. Okay. Now, is everything about the right length? That is a little bit too long. That has never been a complaint for me. I believe that we can make do with that. Cannot we? Canteth we? Yeseth. Alright. You, sir, would you like some tin? Yes, please, tin me. No, don't melt my insulation off. Turn your stupid soldering iron down. But then I can't solder. No. Hello, pin on the card. Would you like a bit of solder as well? Yes, please, solder me. Oh, I like that. Oh, yes. Now, connect it. Yes. Connect you. Let's connect you. Stay a while and be connected. Stay a while and be connected. Ow. Ah, that'll do. It's not my best work. None of my work is my best work. Because I am nothing if not a hack. Went through good, alright. We'll trim you. That ought to do it. Maybe I ought to put a little bit of insurance on there, just in case, if my insurance isn't dried up. Alright, now we have to get the cap on without letting go. Hey, quit your leaking. Quit your leaking. Now that'll be glued on there next time I want to use it. I'll have to go get a brand new tube. Oh well. Blowing on super glue doesn't do a shitting thing, does it? I always do anyway, just because I'm dumb though. But, you know. Okay. I gotta get some on my fingers so I can glue myself to everything though. Because it's just not a good day unless I super glue myself all over the place. Let's check continuity between this stuff and that 12-volt line just to make sure everything is happy. So we do not want 12 volts making its way in there. That would be unfortunate for all parties involved, wouldn't it? So this should not connect to this. Excellent, but it should connect. This pin should connect to this through a resistor. We'll have to use our ohm setting for that. 470. Did I just use a 470K No, 0.47K. Okay, I about shit myself. I was going to have to redo all of that. I have used a 470K resistor instead of a 470 ohm resistor before, and then wondered why my LED doesn't light up very good. Wonder why that could be. Okay, I gotta clean up my junk now, and then we'll zoom back out and install it. I'll change your angle a little bit so hopefully you can see that bitty LED on the bottom there. The power LED is on top, and this header that still has the power LED on it, speaking of the power LED, will need to be plugged back where it is supposed to go. Right there. You wires, you can stay out of the way if you'd like, and we'll feed these down under here. Oh, get down there out of the way. It'll plug into our card, which will, well, our card will be over here now. Let's use this good cable, this ATA cable, pin 1, and the red stripe, yes, 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 yes. Everything is all is well. All is well. And then our card plugs into our socket that we added to the riser down here. there. It's in there quite well. I don't think that'll go anywhere. Now this cable needs to plug into the drive this way, so we're going to have to do a little bit of routing. Something like this. That should give us a good doohoo there. And then, now, which way will this need to be plugged in? Let's try that before we put the drive back, otherwise we won't be able to get in there very well and reverse it if we have to. I'm blind, I'm blind! There we go. Now, let's see what happens here. Well, I didn't see any smoke come out of it. Hopefully we'll see a blip when it probes the IDE interface, assuming I didn't just break the IDE interface. Did you? I wasn't watching the stupid thing. Did you see a blip? I didn't see a blip. We must have it plugged in backwards. Let's turn it over. If you weren't aware, LEDs being diodes only pass current in one direction. Oh, I saw a blip. Oh, look, it's working. It's working. Excellent. I think the brightness is alright. FreeDOS doesn't have ScanDisk, it does have DOS FSCK though, so I'm going to run it to generate some hard drive activity, and that ought to tell us whether or not our brightness is alright. It looks a little dim, doesn't it? Well, no, when the drive is going full bore, I think it's alright. Well, I still need to clean up the top cover, but you can tell that he is going to be a pretty boy. Yeah, and our LED there looks pretty good. Things are working. Yeah, you know, I think that we need some kind of gnarly old tape drive in this space right here. Yeah. Whatever the thing, or I could just put that DVD-ROM in there. That burner, that would probably be more useful in case I ever happen to come across some DOS games on CD or something like that. That have like CD music and shit, you know. But that 5 1/4 inch bay requires rails, the kind that have the tab that the screw goes into on the outside. I don't think I've got any of those anywhere. If I do, they're buried in a box somewhere out in the shed. And oh Lord, that will be an adventure. But yeah, he's going to be a pretty boy. Look at all that. I mean, that integrated like floppy drive thing going on there. Is that pretty or what? Yeah. Anyway, see you later for real this time. Thanks for watching.